So for 14, okay, for 14, you have two figures there. So with the two figures, you have to figure out each one individually. So for the top one, you have this figure. Okay, it's a triangular prism. Okay, so I am looking at that figure. Okay, triangular prism. And then for the second figure, I'm looking at the rectangular prism. Okay. Use this one. Okay. So for number one, height. Well, first of all, wait, back up. What's the basis of this guy? What's the one with the least amount of shapes? Triangle. Everybody see that? Yes? Okay. So the height that goes in between the two triangles on that shape is what? 15. How do you know that? You mean the line? Yeah, the line between the two spaces. So it's this guy. So it's this one. Okay, that goes between. Do you see that? Yeah?
Yeah.
Okay. That's why I highlighted there and there. Okay. So that's the height of the figure. Okay, the height of the figure. Then the perimeter of the triangle. Okay. These two lines right here, the 9 can be brought up to there. Okay, so we have 9 there, and this 9 over here. Okay, so that's how we get that right there. So the area of the triangle, 1/2 base times height. Okay, base times height. So the base is 9, the height is 7.8. So you get 35.1. Now, listen to me very carefully, you guys. You don't have to, actually, before I do that, before I do the area of the triangle, what you should do, taking this information, you should find the lateral area, which would be the 15 times the 27. Okay, should do that first, which is right there. Okay, and then when you get that information, okay, you're going to add that to your area of your triangle. Now, do not round in the middle of your problem. Please, please, please. You're going to get a different answer. Okay, don't round in the middle. So, this is your area of your triangular prism, okay? Then you go through and do the area of your rectangular prism, okay? That's just with your 2 times. That's the first formula that we did. Once you get this, so you have your area of your triangular prism, your area of your rectangular prism, down here, there's your rectangular, there's your rectangular, there's your triangular prism. You get this answer right here. Here's your answer. Why are we doing this right here? Well, here's the deal. And I know the people on the video can't see this, so sorry. But when you put the triangular prism on top of the rectangular prism, okay, I want you to think about this. When you go to wrap this figure with wrapping paper. Okay? You go to wrap this figure with wrapping paper. You are only wrapping the outside of these two figures, correct? Yes?
Yeah.
Okay. But you took the surface area of this figure.
Yeah.
So now I just pulled off the triangular figure off the rectangular figure. I am now wrapping this entire figure, including this base. This one, I'm sorry, one of the faces. I'm wrapping the entire figure of this rectangular prism. But watch what happens when I put the two together.
Oh, yeah.
There are two faces that should not be wrapped. What two faces?
The bases.
They're not bases.
The faces.
What are these figures?
Squares.
Well, they're actually rectangles.
Okay.
Okay? They're rectangles. We've got to subtract those out. That's what they're doing right here. They're subtracting them out. The best way I can explain this, guys, is that if you go to wrap this with wrapping paper, okay? These faces that are touching won't be wrapped. So, again, let's say we wrap these figures, okay? We wrap them individually. Wrap them individually. It's Hanukkah or it's Christmas, whichever one you celebrate, okay? We wrap them individually. And then you decide, oh gosh, they're for the same person. Put them together. You put them together. We wasted some wrapping paper, didn't we? Hello? We wasted it. Which part did we waste? What did we waste? How much wrapping paper? Explain, not in geometry terms, but what did we waste? But which two sides? Which ones are those? Which ones are the ones that we...
The two sides that are touching from the two different figures.
There we go. The two sides that are touching from the two figures. The wrapping paper that we wasted are the two sides that are touching in the two figures. We have to subtract that out. That's this right here. You guys, SATs, ACTs love these problems. They love these problems. Okay, swimmers? Are any swimmers on here? In here? No? Alright, so number 15. Okay, number 15. Number 15, all of this inside is finding a cylinder. All of this inside is finding a cylinder. Okay? Surface area for a cylinder. This 1/2 means I'm taking this cylinder and cutting it in half. Just like if I was to find a sphere and cut it in half. I can't cut this in half. I don't have a cylinder that's half. Okay? But if I cut this cylinder in half, what do you think is on the bottom of that cylinder? A rectangle. Think of, I don't know, think of a hot dog. You ever cut hot dogs in half?
Yeah.
There's a rectangle. You split them in half and open face. There are rectangles on the inside. So here's the surface area of the cylinder right here. Okay, that gives you the cylinder. So surface area of the cylinder. Okay? So that's half the cylinder. And then 6 times the 25 is the rectangle that's on the bottom. Down there. Okay? It's on the bottom down there. questions?
So you find the surface area of the circle as you regularly would, and then you divide by 2 since it's cut in half.
The cylinder.
The cylinder. And then you would find the surface area of the rectangle below it. And then you would add that, or
You would add the rectangle to it.
okay.
Okay. So for this, you've got a pyramid, okay, with a square bottom. The height always comes down from the vertex top down to the base. Okay, that's always the height. Okay, that black line on the face of the pyramid that I drew on my wonderful little blue 3D object is the slant height, which is the L. Okay, that's your L. What will happen is you will connect this line right there. Okay, and the height that goes from the vertex at the top down to this line right here will connect to the slant height. The 90 is over on that side, but it can also be put on that side. Okay. Do you guys see the triangle inside? Yes, no? Okay. You guys see this triangle inside? So you have that right triangle. You can do your Pythagorean there. So we look down here. L is your slant height. P is your perimeter still. Area base we've already changed. Okay? Because the bases could change. Alright. So we're looking at number 1. What kind of a base is that? What type of base? How do we know it's a square? There's another reason.
There are 4 right angles.
4 right angles, and the 8 by 8 supports it. Okay, but the 4 right angle makes it, because we could have a rhombus. Okay, so the 4 right angles in there. Okay, the 4 right angles tells you that it's a square. Okay, so that's 8, that's 8, this is 8, and back there is 8. Okay? Yeah, but because it's stating that that's 8 and that's 8, 2 of them together are stating it's a square. That's why it's saying the 4 right angles and now with the 8. You can't just say the 8. Okay, they have to be going hand in hand. Okay, so we have our slant height, which is 11.7. We need our perimeter. How do we find our perimeter? Oh, Hannah, how do we find our perimeter, everybody? Add up all the sides. Someone in the back table, tell me how to do it. Back table. How do I find my perimeter of the base?
8 plus 1.7 plus
8 plus 8 plus 8 plus 8, which is 4 times 8, 32. Find the lateral area. So back over here at the lateral area for a second. You can also write this as LP over 2, which I always like to put the fraction over 2. Okay, it's always easier. So the lateral area is 11.7 over 32 divided by 2. Okay. So my lateral area is equal to, this goes into that, 16. What's 11.7 times 16? Somebody. Anybody. Okay, great.
187.2.
187.2 meters squared. Don't erase that in your calculators. This is what I was trying to get you guys to not do. So when you find an answer, okay, in your calculator, don't erase it because you're going to now use it for the next problem. Okay, you're going to use it. So surface area is your lateral area plus the area of the base. Area of the base is a square, so my lateral area is 187.2. Okay, here is your plug-in. Okay, here comes your plug-in right here. How do we find the area of a square?
It's one side squared.
One side squared, or side times side, side squared, whatever. So it's going to be 8 times 8, or 8 squared. That's your plug-in. So you already have this in your calculator. You know that, hopefully, 8 squared is 64. So surface area is going to equal,
251.2.
what was it, 251.2 meters squared. Beautiful. Yes. For 3, and let's do a little bit darker. All right, we want to find the slant height because we need it. So slant height goes there. We need to find, we have that. I don't think so, but we do. That's 90 degrees.
Right?
So we're going to use this triangle right there. And because this right here is going to, the height from the tip of the pyramid, top of the pyramid, down is right in the center. This right here is half, so it's going to be 8. So if I pull this triangle out, we've got 8, 3, and this is your slant height. Get the answer here, because it's going to be, let's see, 3 squared plus 8 squared equals L squared, which is 9 plus 64 equals L squared. 73 equals L squared. So L is equal to the square root of 73, which we know is not going to come out nice and pretty. Okay, here's my suggestion, you guys. Don't multiply that out just yet. And if you did, don't erase it. Okay, so what's the perimeter? Somebody muted me. So lateral area is going to be the square root of 73 times the 64. Okay? Actually, I'll write it the other way around. 64 square root 73. Surface area is going to equal 64 square root 70. How did I impose that? 73 plus the area of what? Area of the what? Area of the square. So surface area is going to equal 64 square root 73 plus 16 squared. Okay, do that in your calculator and tell me. Oh, okay, there's a mistake. I did a mistake. So this is going to be divided by 2, which is going to be 32 square root 73. Yeah? Better? Yes? Okay. So 32 square root 73 plus 16 squared. Okay. Much better. Thank you for correcting that. Okay. Find that area. Oh, okay, so let me put that in again. What is it? 529.4 feet squared. Good. So here's the plug-in. Here's the plug-in. Okay? So for this one, right here, you're going to have to use this as your Pythagorean theorem when needed. This right here, again, I'm not sure why they're doing the area of the circle and then the lateral area. I really don't know. But this is your area of your circle. And then this is your lateral area. I'm really not sure why they do that. If you want to write it the other way, go ahead.
You have to do like lateral area before you solve.
You always have to get your lateral area. It's actually easier.
It's already in. You could use SA is equal to pi r squared plus pi RL and then just plug it in.
If I ask for lateral area and surface area, yes. And honestly, on a test or quiz, I actually ask for it. Okay? Because why bother having you solve for it if I don't give you points? I think it's a waste of you doing work if I don't give you points for it. Okay, so for this one, straightforward. Very, very straightforward, okay, you guys? So, lateral area. Pi times the 7 times the 11.4. Okay? That's your lateral area. Gives it all to you. Surface area. Okay? Take this entire thing plus your pi r squared. So surface area is equal to whatever this is plus pi times 7 squared. Whatever that is, meters squared. Okay, so multiply this out so that you just use pi. Okay, so 79.8 pi plus pi r squared. So 79.8 pi plus pi times 7 squared. So 79.8 pi plus 49 pi. Add the 79.8 plus 49. Correct. 128 point pi. Now multiply that by the pi. 404. 63, so it's 6 meters squared. Okay? The reason I did it that way is because you can combine the numbers when it's a pi. Now and you don't have to round. Because you can use the pi as just like it's a variable.
What's the m squared at the end?
The units?
Oh.
Okay. For this one, we need the radius. If the diameter is 27, what's the radius? Okay, that's the radius. You guys can go from there. On number 9, we need to find the radius. So here's my triangle. So if I pull this out, I have my radius is r, my slant height is 27.3, and my height is 25.2. Use your Pythagorean theorem. Okay. And number 11, another problem like this where you have to do the wrapping paper idea. Okay, another problem like you have to do the wrapping paper idea. Okay, that takes us to the end of the notes.